Morning, one and all. I am Mrs. Nisha Shirkoli, Assistant Professor, Department of Pharmaceutical Quality Assurance from KLA College of Pharmacy, Belagavi. Going to cover today the topic for waste disposal management. Now we know around, if I can say, we come on to statistics of waste disposal. Around 292 million of waste is generated every year. This is a municipal waste. From that, only 69.1% is actually which is recycled, which is very less amount. Now today we are going to cover basically biomedical waste management, which will include the waste from pharmaceutical industries as well as from medical, hospitals and all those things. So now this term is generated by or given by specified by Section Act 1990 and of Waste Disposal Management, okay, acts has come by European Environmental Agency. So we come to the definition of waste, which includes any effluent, unwanted surplus substances which requires disposal as it worn out, contaminated, spoiled, or they are not in the chain of commercial utility. We are not going to utilize them any commercially, or all those things can be considered as waste. Now, even it can be called as surplus material. Surplus material will be any extra amount of the material which is generated and which is then later on unrequired or unwanted. Now we'll come to the obsolete waste, which will be the waste which is no longer which we can use. Okay, we cannot use that waste again. Obsolescence will be the materials which we don't require anymore, but that can be recycled and can be used. Now, if we categorize broadly, if we categorize the waste, there are biodegradable waste and non-biodegradable waste. So, biodegradable waste are the waste which can be degraded. Okay, either they can be decomposed or any other techniques can be used where they can be degraded. So, examples for that are paper, wood, fruits, pharmaceutical waste, biomedical waste. Okay, some of these can be degraded. Okay, and non-biodegradable waste will be plastics, oils, machines, cans, which can be recycled. Okay, they cannot be biodegraded, but they can be recycled. And even they can waste can be categorized as hazardous waste and non-hazardous waste. Now, hazardous waste we know which will be unsafe for use for human use, and non-hazardous waste will be safe for use. Okay, we can later on use them. We can recycle and we can use them, and there will be no infection or any what you call harm to the human beings. Okay, through that. So next we'll come to what you call generation of pharmaceutical product waste, where all the waste in pharmaceutical industries is generated from. So during majority of the manufacturing processes, this waste is generated. We can say during weighing, filtering, milling, transferring, there will be any spillage, or we do so many QC tests. Okay, in process quality control test, where we'll be doing weight variation, volume checks, okay, hardness test, for all this friability tests. Okay, these are all the in process checks which are done during the tablet manufacturing. So during this processes there is lot of waste. Okay, those have to be discarded. Those samples which we take have to be discarded. Okay, even during compression, coating, filling, packaging, in all the areas of tablet manufacturing, or we can broadly say any pharmaceutical manufacturing, there will be waste generated. Even during the packaging of the products, okay, like leaflets, cartons, foils, okay, packaging processes. What happens if we are going to put the date, okay, today's date, we are going to emboss them or imprint them with today's date, and later on we are not going to use them today. Obviously, that will be considered as a waste. Okay, we cannot use them. Either we can dispose them off or we have to recycle them. Okay. Next, we will come to the different legislations in India for waste. So the Air Prevention and Control of Pollution Act, which is established in the year 1981, and the rules came in 1982. Now, major difference between Act and rule is, okay, Act is a law passed by government. Now, rules help these laws for governing. Okay, it's just rules are the helping hands. Okay, they are not what you call any law. We can call it as a bill. Okay. So next is the Water Act 1974. It was passed in 1974, and the rules were passed in 1975. The Environmental Protection Act and rules, which was what you call established in the year 1977, hazardous waste management and handling rules in 1989. Now today we are going to cover majority of biomedical waste management and handling rules 1998. Okay, these are the majority of the rules which we are going to understand today, and how the waste is going to be disposed of, or how we are going to handle any biomedical waste. Now can see there are some of the terms, okay, ingredients of pharmaceutical waste, and other limits which are permitted per liter. Okay, if you're going to produce anything today, so per liter how much of the can liter, or which is permitted according to this acts and rules. So oil and grease, if we go to see, it's only 10 mg per liter is permitted. If we go to see mercury, hardly the permitted limit is zero point 0.1 mg per liter. So hence on we can see the other. Now arsenic and chromium, these are leads, these are all what you call, they are hazardous to our nature. Okay, they are very hazardous or harmful for human beings. So this all the limits have been specified in this acts and rules. Next, if we come to see, okay, there are the methods of disposal which we need to follow. Okay, now first one, return to the manufacturer. So which drugs will be manufactured? So the unused drugs like anti-cancerous drug, okay, antibacterial drugs, okay, which we don't require, which are expired, we have to return them back to the manufacturer. So majorly here we are talking about the pharmacies, or what you call medical shops in which the drugs are expired. Okay, so these drugs have to be returned to the manufacturer, and where the manufacturer will accept them, they'll evaluate them, and then they are going to dispose them of accordingly. What is the another method which is a very broadly used method? Okay, landfill method. This is the type of waste disposal which is used broadly. Okay, now for we can categorize them again as solid waste or liquid waste. Okay, cytotoxic wastes are there. Now even radioactive wastes are there, which will be generated from radiopharmaceuticals. Okay, we have what you call genotoxic waste also. Okay, microbiological waste from the laboratories and all those things. So majorly these things, okay, they are landfilled. Okay, we cannot incinerate them or all those things. Okay, thing is for solid waste, very common old, this is a very old and widely accepted waste disposal method which we use. Uh, we directly place the waste into the land. Directly we are going to collect the waste and we are going to dump it into the land. Now there are three types of landfills. One, uncontrolled non-engineered dump landfill, which untreated, we are not going to treat the waste here. We are just going to make a dump and we are just going to put all our waste there. Okay, we are not going to use them later on. This is non-engineered. There is nothing, what you call, any process involved for landfilling. Whereas we go for engineered landfilling, okay, this dump landfills is features to protect the environment. It has a coverage. Okay, what we do here, we mix the waste with any cement and lime and we grind them. Okay, and then we are going to do the landfill. So what will happen, this waste will not go into the soil, or it will not, what you call, destroy the what you call, contaminate the soil. Okay, overall, so that can be done. Next thing is highly engineered sanitary landfill. So this is not widely used, but this is the preferred one. Okay, we have, if we go by this highly engineered sanitary landfill, it is the best. So what is it? Constructed and operated landfill sites offering safe route of pharmaceutical waste disposal. Okay, if we are going to dump by this method, first of all we are going to convert the waste into a non-hazardous thing, and then we are going to landfill it. And whatever the what you call fumes, or what you call any extra thing which is generated, it will be engineered and it will be made non-toxic. So next method is waste immobilization, or we call this a encapsulation. So here we what do we take some huge steel drums, and in that we put our waste and we immobilize them. Then what we do, we take them to the waste disposal area where we are going to actually dispose them out. So what will happen here, we are just going to encapsulate the whole and we are going to squeeze all the waste. We are going to reduce its size. Okay. So later on, very important part is we have to clean the drums later to prevent the traces of any materials which may be hazardous. Okay. Next is waste inertization. So here what we do, for a landfill method. Okay, before I discussed for engineered landfill method, what we do here, we remove the dosage forms. Okay, any blister packs are there, any packaging materials are there. We add water in that. We add cement, lime, and then we grind it. Okay, we make a homogeneous paste, and then we transfer it into a landfill. So what will happen? They'll dry and they'll make a big, what do you call, immobilized waste, which will not go into the soil and it will not contaminate our soil. Next, we'll go for the sewer. This is largely used for the liquid dosage forms, syrups, IV fluids. Okay, which what we do here is we dilute these liquids with water and we flush them in the, what do you call, wherever the sewage is there or wherever flowing water is there. Okay, so there is no contamination. Next is incineration. This is the best method which can be used for hazardous waste. Okay, so we can either apply high temperature, which are used for more than 1% if in case halogenated compounds are there, and medium temperature furnace is operating minimum of 850 degrees centigrade, which is used to treat most of the expired solid dosage forms or expired drugs, the formulations which we come back from the pharmacy. Okay, not only pharmacy. Sometimes we manufacture we more than required quantity. Okay, then they expire. So these drugs are also inserted. Next is steps to dispose of waste. So handling of pharmaceutical waste, it's in, what do you call, it's in whole and sole responsibility of the production employees, quality assurance personnel, and how we are going to handle them. There should be no misuse or any accidents. So what we are going to do, we are going to treat this pharmaceutical waste. For this, there are written procedures, there are accepted SOPs, there are standard operating procedures. So we are going to follow them. And now these all things are mentioned in the act, how we are going to. Next is, okay, how we are going to handle the waste. These are the broad steps which are involved in handling the waste. So first you're going to evaluate a waste, whether it is hazardous, whether it is non-hazardous, okay, whether if we go to states of matter, at either it is solid, liquid waste, then we are going to store our waste. Now, if we go for storage, okay, handling of hazardous waste is very important. Okay, we have to mention, we have to label them correctly as hazardous waste. Okay, even we have to store this waste at an impermeable space so that there is no contamination by this hazardous waste. Okay, we have to make it sturdy. Okay, we have to make it completely intact. Okay, so that there is no environmental contamination as well. And we have to label them accordingly. In case it is hazardous, we have to mention it hazardous waste. Next is, okay, what we are going to do after, okay, labeling them, after storing them, after categorizing or classifying them, we are going to transport and dispose their waste properly. Then what we are going to do, it is very important to plan for any emergencies. Now here emergencies means when we are going to transfer this hazardous waste, there may be spillage. Okay, so we have to be ready. There should be necessary equipments. There should be necessary, okay, apparatuses ready to handle that emergency. Okay, in case there is any spillage. Now, obviously, now we have to train the personnel for this emergencies or for hazardous waste, how we are going to dispose of. So again, training is given to all the persons who are going to handle this waste. And last but not important is we are supposed to keep the record of the waste. Okay, so it is very important to keep the records for the waste. Now, all the details of hazardous waste, whether it be non-hazardous, hazardous, expired risk, it is very important to keep the records where we are actually going to dump them out or dose them out. Okay. So next, if we come, these are some of the examples. Okay, I have mentioned for method of disposing the pharmaceutical waste. So here we can see empty containers of bulky materials. Okay, what are the methods which they use to dispose them of? So they are either rinsed with the water. We are going to remove the labels and then we are going to dispose them out. If we go for powders, granules, tablets, capsules, okay, solid dosage form, okay, we are going to make a solution with water. Either we are going to add a suitable solvent in which this can be dissolved and we are going to pour them into effluent treatment plant. This is a plant, okay, effluent treatment plant is a plant where we convert this hazardous waste or what you call chemicals into a non-toxic waste. Okay, it's very important to treat. And sometimes, okay, this liquids or whatever, what you call, liquid formulations are there, IV fluids are there. After going into effluent treatment plant, we can even reuse the water for the gardening, okay, only for gardening or for the washroom purpose. Next is sanitary purpose. For oral and parenteral preparation, we are going to pour them directly into effluent treatment plant. Similarly, we can see the examples for labeled bottles or printed labels. Okay, they are destroyed. Now, printed labels, carton boxes, leaflets or papers, boxes. Okay, these are all, cardboards. These are all disposed by or destroyed by incineration. Just to dispose pharmaceutical waste, if we are going to categorize them, okay, according to the states of matter. So solids can be landfilled, semi-solids they have to be encapsulated in steel drum, powders can be incinerated at high temperature, liquids can be okay, flushed off in the sewer, ampules can be crushed and then we can flush them to sewer, or you can even what do you call, landfill them. Next, similar way we can see aerosol canisters. Okay, they and filled. They have to first crushed. We have to remove the propellant if anything is remaining, and then we are going to landfill them. Paper, cardboard. These are all the things we can reuse them. Okay, recycle them. The best. Before also I said hardly 69.1%, 69.1 ton of the waste is actually recycled. So it is very important. Develop the methods where we can recycle them. So handling of the biomedical waste, okay, as per Drug and Cosmetic Acts rules, handling and disposal should be done according to the this Act Biomedical Waste Management Rules, which was established in the year 1998. Now, if we are going to talk about treatment of biomedical waste, first we are going to sort them out categorically. We are going to separate them in areas. We are going to pack them, store them separately. We are going to give different color codes in case there is. So I'm going to categorize them further. You can see what are the different color codes given, okay, for different types of waste. Then we have to carry those containers to what you call suitable place according to schedule 3 and 3 where you are going to dump them off. Then you are going to destroy them according to the procedures and you are going to maintain the record. So this is a brief procedure of how a biomedical waste is treated. Next, we come to what you call methods to dispose the biomedical waste exactly. So human waste, okay, organs are there, tissues are there, which are generated in the hospitals. Either they can be incinerated, either we can deep bury them. Okay, animal waste is there. We can even convert them into biogas. Okay, we can use different methods like composting, burial, manure pits can be done. Okay, so microbiological waste, obviously they have to first autoclave, they have to first disinfect them, then incinerate. Sharp waste are like blades are there, needles are there, scalpels are there, syringes are there. Okay, they have to be first disinfected and they are to be autoclaved and they are to be dumped off. Cytotoxic, especially this what do you call they, which are toxic to us, they have to be incinerated. Solid waste, if we call the surgical waste, okay, they have to be autoclaved and they are to be incinerated. Next is tubings, catheters, IV stents, okay, they have to be disinfected. So further on, we can see. Thing is, okay, color coding, I already told you the color coding is given for all the biomedical waste. So broadly, yellow color is given for human and animal anatomical waste, which are to be incinerated and either they can be deeply buried. Now, red color is given for the surgical equipments or surgical apparatuses, like tubings are there, catheters are there, IV sets are there. They have to be autoclaved, microwaved. They are to be chemically treated to remove what you call any infections if they can produce, and then we are going to go for landfill. Now, blue or white color label is given for the waste for sharp needles, syringes, scalpels, blade. Okay, they are to be autoclaved and then they are either going to be shredded or discarded. Next, last, black color is given for the cytotoxic drugs or incinerated ash for expired drugs. Okay, for expired drugs also we are going to any spurious drugs. There are lot many R&D R&D trial batches which are there, so they are also given black color and then they are to be disposed of. You last but not least, I would just like to tell you there are lot many domestic waste also which we produce at home also. Please categorize them as wet waste and dry waste, so that the wet waste can be used, they can be used for composting or manure, and later on they can be used as manure for our plants. Okay, so lastly I would just like to say, please reduce, reuse and recycle any waste which is possible. Thank you.